the square of the time period is directly proportional to the cube of your semi-major axis. That concept is your law of periods. If its speed is 11.2 km per second, then only we can say that it just escapes the Earth's gravity. So escaping of the Earth's gravity is called as escape speed. Earth satellites can be classified as two types. One is natural satellites, artificial or man-made satellites. Hello everyone, I'm Brinda from Department of Physics. I welcome you to the session 1 of chapter 8, that is gravitation. So today in this class we study about something more about the gravitational concepts of our Earth. So now, what is a gravity? Gravity is the one which acts with respect to one object with respect to the Earth. And what about the gravitation? There's a difference between gravity and gravitation. Gravity acts only with respect to an object which is within the Earth as well as the Earth. But gravitation is the one which corresponds to the one planet or one body to the another body. Okay. So this is actually the differences between this gravity as well as gravitation, for which you have a law called as universal law of gravitation. So what is this universal law of gravitation tells? That is, the force of attraction between two objects is directly proportional to the product of mass of two objects and inversely proportional to square of the distance between them. Suppose if you consider two objects over here, one with mass caps m, another one is small letter m. The distance between these two is considered to be r square. So the product of masses and inversely proportional to square of the distance between them. That force of attraction is given over here. So as you remove this proportionality constant, you have a g mm divided by r square. So this is called as g. Here it's termed as gravitation, universal law of gravitation. This is the expression of universal law of gravitation. Okay, and this is the gravitational constant which is given in terms of g. M and m is said to be the product of masses and r is nothing but the square of the distance between two objects. So that's all about your gravitation, universal law of gravitation concept. So here in this case we know that gravitational force is one of the fundamental forces of nature. So this fundamental force is called as a weak force in nature, that is the gravitational force. So now we have the relationship between small letter g, that is gravity, and gravitational force. So we'll have to check the relation between these two concepts. So in order to check this, we know that F is equal to m into a, that is mass into acceleration due to Newton's second law of motion. And we know that the force can be equated as the work done, which is equal to mass is exactly the mass, and a can be considered as gravity. So this is the gravity which is within the earth. And the value of this g is 9.8 meter per second square, because the value of this gravity differs from one place to another place, that is from pole to the equator. But when it differs, what happens? We can approximate it to one value, and that approximation of the value is given as 9.8 meter per second square. So we have W is equal to mg over here. So this can even be written as, or F is equal to mg as well. And we also have F is equal to g mm divided by r square. This is with respect to the Newton's universal law of gravitation. So now as we relate it, we have F is equal to ma, that means it is written as g because a is considered as acceleration due to gravity. So we have on equating this with this, that is equation 1 and equation 2. F as well as F, we have m into g is equal to g of mm divided by r square. So your m cancels with m. So we have g r square is equal to gm, or even you can directly write it as g is equal to gm divided by r square, where r is the radius of the earth. You can write it in capital letter R as well. So however you consider, you can actually mention it. Okay. So this is the relationship between G as well as G, which is directly proportional to each other. G is equal to G. Okay. After finding out the relation between G and G, next we can go to the Kepler's law. So we have a law called as Kepler's law of planetary motion. Just to know a brief about it, we have three types. One is law of orbits, that is the first law. Next is law of area, second law, and third law is law of periods. So we have three types of law of orbits, law of area, as well as law of periods. So in case of this law of orbits, we can actually see that the sun is at the focus and the planets revolve around the sun elliptically, that is in an elliptical orbit is what it is telling. That is Kepler's law of orbit. The orbit around the sun is said to be in a elliptical way. What is called as law of area? That means to say, sun is at the focus and the planet is revolving elliptically, but at this condition, if suppose there is a planet over here and after certain interval of area, if suppose the planet is here, that means the planet which is revolving around the sun sweeps equal areas in equal interval of time is what your law of area tells. Next is law of periods. In this case, we can see that the square of the time period is directly proportional to the cube of your semi-major axis. That concept is your law of periods. So you have your elliptical orbit. This is major axis. Half of it is called as semi-major axis. So time period of its orbit, that square of time period of its orbiting is proportional to cube of its semi-major axis is what your law of period tells. So that's all about your Kepler's law of planetary motion. So now let us study about variation of gravity with respect to altitude. Variation of gravity with respect to altitude, that is g with respect to the height. Suppose if there is a earth and gravity acts at this radius, and let us call this radius as r, radius of the earth. Suppose we have to see what is the acceleration due to gravity at this height, that is g, and this height is said to be h. Then we can actually see that we have g is equal to gm divided by r square. So gm is nothing but equal to g and r square. So the same thing, if we just apply there, we have g is equal to gm divided by r square. This is the general equation of the relation between g and g. And with respect to r, we have, that is the radius is what, the total radius is what we'll have to calculate, radius plus h. At that position, what is your g value? So it is r plus h the whole square. So substitute g for gm. Gm is g r square divided by r plus h the whole square. So for this we have taking r square outside. So since this is the second acceleration due to gravity, we can consider it as g. This is a general form. G dash is equal to g, taking r square out, we have r square divided by r square into 1 plus h divided by r whole r square. Okay, so r square cancel. So we have g dash is equal to g of 1 plus h divided by r and minus 2 since it comes to the numerator. So this is the final expression for your variation of gravity with respect to the altitude. Now let us check the variation of the same gravity, what happens in case of your depth. At height we have seen, now let us check with respect to the depth. Variation of g with respect to depth. So we know that g is equal to gm divided by r square, which is the general notation, for which we have density. If we just take the density, because the density of the earth within the depth we are checking. So density is mass by volume. So mass and volume is with respect to the earth itself. So it is spherical in shape. So volume of a sphere is 4 by 3 pi r cube, and we have a mass given as m, which is equal to m dash. We are equating the mass of the sphere with the mass of the normal, like with respect to the depth. M dash is 4 by 3 pi, r is r minus depth, you can call it as minus d, the cube, whole cube. So we have here m dash is equal to m into r minus d the whole cube divided by r cube. Consider this equation and applying with respect to the depth, g dash is equal to gm dash divided by r minus d the whole square. So applying with in equation 2, that is m value in equation 2, we have g dash is equal to g, m dash is m r minus d the whole cube divided by r cube into, take this 1 minus r minus d the whole square. 1 cancels with, the square cancels with this cube. G dash is equal to gm r minus d divided by r cube. So we have this set of equation. Now let us just check, this is said to be equation 3, this is said to be equation 2. On equating equation 3 and 1, that is g dash divided by g is equal to gm r minus d divided by r cube into your m value gm into gm. So gm divided by r square. Square cancels with 1r, gm cancels, so we are left with g dash is equal to, your g goes to the other side, g of r minus d divided by r. So this is one set of equation. You can take the common out, that is comes g dash is equal to g of r, and r gets cancelled, so it is 1 minus d by r. This is the final expression in case of your depth, that is variation of acceleration due to gravity at the depth. Okay, so this is all about your derivation. Next, let us just move to the escape speed. What is your escape speed? So here you can see that this is the earth, and you can see a light gray line over here, which means to say that once an object is ejected out of the earth, probably it's a rocket for example, if you take, if it has to cross the gravity, it has to reach up to 11.2 kilometers per second. So if its speed is 11.2 kilometer per second, then only we can say that it just escapes the earth's gravity. So escaping of the earth's gravity is called as escape speed. That is the minimum velocity that has to be achieved by an object to escape the gravitational influence of this celestial body is called as escape speed. And the formula for this is given as escape velocity is equal to root 2 g and r. So this can be used as the formula for this escape speed. Next, we are going to Earth satellites. So what are the types of satellites? The satellites are the one which collects the information of the world for a short interval of time. So you can see that follows the bird's eye view. Okay, that means the satellites are situated at the top of the earth. So it can capture all the informations of the world. Okay, as the bird can see many of the places at a time, it can capture most of the information from the earth at a time. So it covers large area of the earth. That is actually the use. It stores the information of what's happening in the earth. So information storage is happening with respect to the satellites. So earth satellites can be classified as two types. One is natural satellites, artificial or man-made satellites. So as you all know, the natural satellites are said to be a moon. Artificial and man-made satellites is said to be the one which is made by us. Okay, so we know what exactly, we send it through our rockets and all, right? And next is what is geostationary satellites and polar satellites. The energy which is required by satellites to revolve around the earth is called as orbiting energy. Okay, so the energy which is required by the satellites in order to revolve, because once it is placed, it has to orbit in its own axis, right? When that's the case, it has to possess certain energy to orbit. Such kind of a concept is called as orbiting energy. So here we have one is geostationary satellites and polar satellites. So as you all can see, polar satellites are the one which is actually revolving at the poles. Like you can see a thin white line over here, which means to say it is the polar satellite's polar orbit. Okay, pole to pole it is. It revolves from pole to pole, North Pole to South Pole. That is the actual use of your polar satellites. But this geostationary satellites, it is the satellites which moves along the axis, along with the Earth itself, it starts rotating. Such kind of a concepts are called as your geostationary satellites, which works for 24 hours, wherein polar satellites is the one which is working for 100 minutes. Okay, so one revolution, it takes 100 minutes, wherein geostationary satellites, it takes 24 hours. That is all about your geostationary satellites as well as polar satellites. So in today's class of ours, we have studied with respect to what is meant by gravitation, universal law of gravitation, types of satellites, what is escape speed, what is orbital velocity or orbital speed, as well as stationary, geostationary satellites, as well as polar satellites. Let us all meet in our next upcoming class with a new chapter and a new session. Until then, have a good day. Thank you.